Hello, welcome to Comms Readiness. My name is Tony Webster. My GMRS call sign is WRNC688, and my amateur radio call sign is K8KTI. I am the comms lead for an Oxford area mutual assistance group. We have commercial frequencies that I've leased for us from the FCC. We have a DMR repeater that we use that does have encryption, which is only available essentially on commercial systems. My amateur license level is general, and I focus a lot on near vertical incident skywave transmissions, which basically lets us go 3 to 500 miles out. And I'm interested in creating stations in the HF and VHF frequencies for hiking and backpacking. Some disclaimers. I'll let you read through these, but these include a license requirement, disclaimer, programming accuracy, no warranty, interference. And on the next page, the information provided in this document represents my views and may not reflect the positions of the Southwest Ohio GMRS Association. All right, so what are we addressing in this presentation? We're considering grid down situations where there may be no mobile phone, Wi-Fi, power, water, some combination of those being out or all of those being out, and about typically out for 24 to 72 hours. And in a situation like this, we clearly want communications with our family, hopefully our local mutual assistance group, emergency responders, police, fire, EMT, et cetera, et cetera. So why should we care about this? Here are some examples from the recent past. If we look at Winter Storm Uri in Texas in 2021, power was out for 5+ days for many residents. 4.5 million Texans were affected, and this storm resulted in more than 200 deaths. Also, more recently, we could look at Hurricane Helene in North Carolina and adjacent states in 2024. Power was out for 2 weeks or longer for some residents. Almost 5 million residents were affected, and 74% of the cell towers in the area were down. So clearly, these are the types of things that can happen in the United States, and I'm here to help you prepare for the first 24 to 72 hours of this type of event. All right, so what are our options for communicating when the grid is down? Basically, there are two big buckets. One is line of sight. So here we are wanting to talk to someone, and we send out a signal, and that's received. It could be received by a plane, it could be received by another person or emergency responders directly. When we do this, we're operating in the very high frequency or ultra high frequency ranges. We could also operate in the high frequency range. And the way that that works is the signals that we send out get bounced off of, or more accurately, refracted through the ionosphere. So these signals can go halfway around the world. We typically would be more interested in sending them out a bit farther than VHF can go, 25 miles, 50 miles, 100 miles, 200 miles, up to 500 miles, something like that, to get regional help and help us facilitate regional communications. Okay, so let's start with line of sight options here. Again, this is VHF or UHF, and you can see the frequencies there that includes in megahertz. And we can think about this as ranges of 0 to 60 miles, of course, depending on the power that we're using to transmit terrain, it's line of sight, so nothing can be in our way, et cetera, et cetera. So communication types that enable this for us are FRS, MERS, GMRS, ham radio, also commercial frequencies leased by the FCC, citizens band radio, and Meshtastic, and things like that. And our second method of communicating is, as we looked at on the prior page, atmospheric bouncing, and also we should include satellite communications in this. So these types of communications would include ham radio on the HF frequencies, about 3 to 30 megahertz. And for regional communications, we should be able to communicate this way, essentially 0 to 600 miles, depending on power and atmospheric conditions. And we also have the option of mobile phone to satellite, and this occurs on the ultra high frequencies, and the range for this is worldwide. And I'll talk more about the options for this in a few pages. So, what are our challenges for grid down communications? One thing that people rarely think of, but is really crucial, is crowds and channel constraints. All of the above options, except for satellite, are one transmission at a time per frequency or per channel. So, what this means with a lot of services like GMRS or MERS or FRS, we might not be able to communicate when we most need to because so many people are trying to use the frequency that we need, the channel that we need. And again, it's one transmission at a time. So this is a huge problem and a huge limitation. Ham radio is an exception to this. There's a essentially infinite amount of frequencies available to ham licensees, but you need a ham license for that, and you can pretty much only communicate with other hams. Another big challenge for us is privacy. So anyone can hear you, and encryption, unless we're talking about commercially leased frequencies, is prohibited. All right, so let's compare some of our grid down comms options, starting with line of sight, VHF, and UHF. So first up is our FRS and MERS services. These are open to everyone. They're very simple to use. It's very low power, half watt to 2 watts typically, no encryption. And these are going to certainly be very crowded during grid down situations. The FRS radios are the types of things you'd buy in a blister pack at Walmart or somewhere like that. That includes 22 channels in the UHF. Frequency is limited to 2 watts. Some channels need to be half a watt. MERS has just 5 channels. It's largely used by commercial operators, but it's open to everybody. And this is set up in the VHF frequencies. Okay, next up is GMRS. And GMRS is pretty great in a lot of ways. You do need an inexpensive license to operate on GMRS frequencies with GMRS radios, but there's no test or anything involved for a GMRS license. It's very inexpensive. It lasts for 10 years, and you can get one license for your whole family. So that's really great. It's very easy to use, and it's got medium power, half watt, going up to 50 watts, which is pretty good. Again, no encryption, no texting. Well, I don't want to say that, very limited texting and geolocating. It is legal to use a program called Rattlegram, which emulates texting quite nicely. You can just Google Rattlegram and learn about that. This is also going to be crowded during grid down situations. It's fully channelized, and it includes just 30 channels, 22 of which are shared with FRS, the Walmart type radios. It also includes 8 repeater channels, which is nice. And the transmission side of the repeater channels is shared with the point-to-point or simplex channels. And the frequency range for GMRS in that UHF range, 460 to 470 megahertz. Next up, we have ham radio. So for ham radio, you do need to get an inexpensive license. And for ham radio, you do have to pass the test, at least what's called a technician level test. It's fairly easy to use. We've jumped up a lot in power. You can go up to 1500 watts, no encryption. And this is not crowded during grid down because it's not channelized within the allowable frequencies for technician level ham operators, you can pick a frequency. And if you hear someone talking on a frequency, just go to another frequency. You're not restricted to, say, the 30 channels that you're restricted to with GMRS. So that's a huge benefit to ham radio. Ham radio has some other nice features. So as I pointed out, it's not channelized. It is okay to use this without a license, a ham radio without a license in emergencies. These have to be very serious, life-threatening type emergencies. But if you're in an emergency situation like that, you may use ham radio frequencies. Also, many of the ham radios themselves can be modified to also include ability to communicate on GMRS, MERS, FRS, and also to listen to weather on the NOAA weather channels. Okay, next up, we have the possibility of commercial communications. And in this case, what you're doing is you're leasing some frequencies from the FCC, and you decide who can be part of the group that communicates on your leased frequencies. It is channelized, but repeaters are allowed. And you can't set this up as a private citizen. You have to set this up as an entity, but one wonderful thing with America is we can all start up sole proprietorship or LLC companies, et cetera. So you can do that and lease some frequencies from the FCC. It's a pretty complicated process to set things up with the FCC after you've set up your entity. And it can cost between 200 and 500 or so dollars to do this. You do require commercial radios to do this, and you do require some sort of comms expert to set this up for you or help you set it up. Pretty high power, 100 watts. Typically, these are geographically limited, so the FCC will give you three or four frequencies or channels to use, for example, in the Southwest Ohio, Northern Kentucky, Southeastern Indiana area. So you wouldn't be able to use those frequencies nationwide. Some benefits of commercial are encryption is allowed, so you can keep all your communications securely within your group. This is not going to be crowded during grid down because you're the only ones allowed to be on these frequencies, and they're not set up as channels by anything else, GMRS, MERS, FRS, etc. And these commercial radios you have to buy for commercial transmission can be set up to also work with GMRS, MERS, FRSM, and get the NOAA weather channels. So this is not legal advice. I don't give any legal advice. There may be restrictions by the FCC on setting up your commercial radio to use these other frequencies. So definitely, if you're going to do this, check with the expert you have helping you get set up so you stay on the right side of the FCC. Next up, we have Citizens Band Radio. Whoops, we want to get back to that. This is free and channelized. It's relatively poor fidelity, mostly AM. There's some FM allowable on CB now. This has poor handy talkie range. It has no encryption. Repeaters aren't allowed. Crowded during grid down. So I'm not going to focus very much on CB in this talk. And this is actually in the HF frequencies around 27 megahertz. Okay, and then there's LoRa communications. So these are things like Meshtastic and Meshcore, very high up in the UHF frequency range, around 900 megahertz. So LoRa is free, mostly channelized, low power. Unless you want to operate as a ham, then you can get high power, but then you have to have your ham license. Everyone you're talking to does, et cetera, et cetera. So let's leave the ham LoRa out of it for now. If you just want to go in as a mere mortal without a ham license, you're restricted to low power. Encryption is allowed, and these LoRa setups are typically short range, 0 to 10 miles, with limited repeater capabilities, and they do require a significant infrastructure build out, and they have a pretty serious learning curve as of right now. The learning curve gets shallower and shallower and less steep every year, but as of right now, it's still pretty steep. All right, so now let's talk about atmospheric bounce and satellite communication. Starting with atmospheric bounce, which again is really refracting through the ionosphere. This is going to be HF frequencies about 3 to 30 megahertz, and you can see a typical setup here that I've done on a hiking field adventure. And you can see on the screen here everyone I've contacted on this day. So you can see it goes pretty far without much energy or much equipment required. All right, so to do this, you do have to get a ham license and you have to pass at least up to what's called the general level. That's a level higher than the technician level. It's fairly complicated to use. It looks pretty simple here, but there's a lot behind all of this. Encryption, as always, not allowed for ham radio. And this is also not going to be crowded during grid down because it's not channelized. If you hear someone on a frequency, just move to another frequency. There's an awful lot of frequencies out there available to hams in the HF portion of the electromagnetic spectrum. Okay, this is downside of this is that it's less reliable than line of sight. For anyone who's seen the film Lone Survivor, you saw an example where they were trying to use HF communications and they weren't getting through. It is dependent on atmospheric conditions. Sometimes they're good, sometimes they're not so good. And of course, you need an HF radio and antenna. That's a different type of radio than anything else we have looked at so far. All right, finally, we've got direct to satellite, and that would be typically mobile phone type of things. And there are now mobile phone services starting to go direct to satellite. The best one, in my humble opinion, far and away, is Starlink. It's available on T-Mobile, and you just use a standard T-Mobile mobile phone that's set up to communicate normally and with satellites. As of right now, it's got limited bandwidth. It's primarily for texting. Voice calls aren't allowed at the time of this recording, but I assume they will be pretty soon. If you do this, you have to worry about government or Musk control. As all of us know who have been watching the Ukraine war, Starlink and Musk have the ability to turn on and off these services whenever they want to. So that's something to think about. And of course, the government could step in at any time and tell Starlink or another company to shut down their service. So that's something to keep in mind. The Verizon is also working on this with Starlink, and they're working on a high bandwidth option with Starlink. And as of the time of this recording, that's maybe 1 or 2 years away. Although Apple has a direct-to-satellite service using the Globalstar satellite, it's far inferior, in my humble opinion. It's very slow, text only, and unlike the Starlink T-Mobile system, you have to aim your phone, which is difficult. And so this is mainly helpful for emergency locating. And next thing for direct to satellite, we have something like the Starlink Mini, which operates in also the UHF frequency. Here is an example of the Starlink Mini being used on a camping trip. And the way that it works is you what the Starlink Mini does is it delivers to you a Wi-Fi router and hotspot. It does require a clear sky view. It does also require 25 to 40 watt continuous power draw. It's very cheap. Subscription 5 to 50 a month. They just went up to $10 to $50 a month, but still that's very cheap. And once again, you've got to worry about the government or Musk control. So what's happening, just to be clear here, is that this is actually the antenna, and there's the Starlink radio built into the same unit. So this is communicating with a variety of satellites simultaneously, up and down, to provide you full internet Wi-Fi. So it's just like something you would see with cable Wi-Fi at your home. It's very fast. It's pretty amazing service. You can also use it with your phones just by using the Wi-Fi calling capability of your smartphone. It can also, of course, do things like texting with things like WhatsApp or Telegram. All right, so here's a little table for you that compares most of the things we have been talking about before, so you can see what might be most appropriate for you. So I'm not going to go through the whole table. I'll open it up and let you pause the video and do that yourself, but I'll just go through an example line. If we're talking about FRS or MERS, it's available to anyone. 2 mile range, probably fair. Is it crowd free during a comms down event? No. Does it allow encryption? No. Signal reliability is pretty much excellent. Expertise level, very, very low. Cost is very low. So you'll be able to see that compared to pretty much everything else we've been looking at in this talk on this page. So feel free to pause the video and take a look.
And on that note, I'd like to say thank you very much for your time and attention to these matters.